Hello everyone, good morning. This is Edson M. Millare and I will show you an Express PCB tutorial. But before creating the PCB process sample, we would need to first create an initial design, build it and test it on a breadboard, fix any errors. For this demonstration, we shall use a drawer burglar alarm circuit, and we'll have to draw first its schematic diagram using Express SCH or schematic. That's now we have the Express SCH open. We could see the empty schematic. Now let us first click on the amp like symbol to place the components like this one. And then we press the passive resistor, passive, let's find that, passive, okay, pressing passive resistor, and then we would click on the schematic diagram for 4 resistors. Well, not including the photoresistor is roughly the location we would like to place them. So let's create 4 resistors, one here, another right around here. Let's place it close. Let's say around here. Yeah, here. And then 2 more. Let's place them here. And then another here. Okay. Now, for next part, one would have to give each of the resistor unique identifiers. Let us right click to our resistor and then choose set component properties like this. Set component properties, and then in the component property box under component ID, let us select auto assign part ID. Program should repeat this to R1. Okay, R1, and then set the value, and we get an OK. Okay, let's do this. Let's zoom it in. Yes. Okay, let's just fix the components. Okay. This one on, and then 100. It's 10K. R2, and then we'll have 10K also here, 10K also, and then for R3, R3 is 100K, which is 100K, and then for the next one, let's set the component property R4, and then setting it to 10K. Okay, I think at this point we have properly labeled all the 4 resistors. Now let us rotate R4 by right clicking it and then select rotate component, and then body left at 90 degrees. Just like that, body left at 90 degrees. this point, now let's add a capacitor, potentiometer, comparator, and transistor to the circuit by first clicking back on the component placement tool. So we would have to place here. At this point, we have also placed the IC National LM311 comparator, and then now we are going to place a semicon transistor, NPN, NPN, transistor NPN, and then we see, well, that's okay. Let's transfer it around this area. That would be better. Yep. And let's just move this little resistor right there. Okay, and then we'll have to add one more resistor. Okay, now we also have a passive potentiometer. Let's just adjust it here. Maybe, yeah, closer here to this area. And then let's put a label on it by clicking set component, and then let's put a sign for R5, and then let's set it at 10k ohms. That would be the value. And then now the end is we're going to now add some components, the photoresistor that we need and the buzzer that don't exist in the library. Let's start with the photoresistor. The easiest way to make new parts is to start with a symbol that's already close to what you already want and modify it. Place a regular resistor on the plate of the layout using the placement tool passive resistor. Let's go to the selection tool, the arrow, and then go to the component menu at the top of and select ungroup component. Okay, at this point, let's first place just a regular resistor right here, just a basic resistor. Well, in a resistor, we'll just have to press the passive resistor. So we'll have to go down again, passive resistor. On a basic passive resistor, let's place one here, a brand new resistor. Okay, and then after which, let us go place that regular resistor, then go to the selection tool, the arrow. Okay, then choose the resistor and go at the component menu at the top. Okay, we're pressing the component, and then ungroup component. What we do next right here is we using the circle shape tool from the tool menu right here. Let us draw a circle around that resistor. Okay, we have now a circle at that resistor. And then select the whole object by using the arrow tool and choose component. Let's choose component. Okay. Let's press component and group to make component. Okay. We would call it as a photoresistor. Its label would be PR1, and then that's that. Okay, then for future use, let's save this by pressing component, save custom component, and then let's just name it as photo resistor. Okay, we have here the photoresistor now. Okay. Okay, let's move on to the next part. The next part of this tutorial would be now let us move the photoresistor to the spot that we would like in the circuit. Let's move it closer to let's move it closer to R5. Okay, it's now closer to R5. Next up is we would have to create the buzzer. Since the buzzer is a polarized device, a good starting point is a polarized capacitor. It's kind of polarized. I don't see the term polarize. Okay, after getting no, I mean after getting polarized capacitor, let's ungroup. No, not that yet. Let's what do we call here again? Let's add a circle first. Okay, we could see it. Now we have a circle, and now we'll go to the menu and then click it all up, and then just like that, we'll have to label it something. Let's call it a BZ1. BZ1. By pressing BZ1, code name CP-2224. Okay. Okay, it's time to move this. Let's now add our connections to power and ground. Let us start with the ground. Okay, let's select power ground. Okay, now we have clicked power ground. Let us place 5 grounds on into the circuit at the bottom of R2 near pins 1 and 4, near the bottom of the capacitor, near the emitter of the BJT, and then near the bottom of the potentiometer. Okay, so let's place it now. Oops. Let's just remove this thing. No, let's rotate it. And another here. And then another here. At this point, we would place more power ground. We will place it right here. And then now we have 1, 2, 3, 4 power ground, and then let's add one more right here. Yes, we have another power ground here. Let's use the let's do again. Let's find a power voltage supply of plus 3 volts. I mean 9 volts. So let's press this. But then let's delete this error that we have made earlier on about the power ground. So let's remove this, cut, and then let's go back here, and then let's add power voltage supply 9 volts here, 1, and then 2, and then somewhere here 3. Yes, somewhere here 3, and then another one right here, another one right here, and then one more here. Yes. Okay, so moving on after that part, we would now let's add in our battery connection. Okay, let us place a miscellaneous battery right here. Oh, sorry. Okay, we have now placed a battery right here. We would need next to place a ground connection and a 9-volt network connection. So let's go to the what we call here again. We would have to find a particular connection named power ground. Power. I think I couldn't see it. Power ground. Power. Ah, yes. It's not supposed to be here. It has to be this label. We would find it here. Let us zoom it back. Okay, we're back in business. Let's place it here. And then, how about the ground? Right about here. And then label. Let's label the battery itself. Let's name the battery. Part number would be. Let's change the component properties. So let's assign the name E01, and then its value is at 9 volts. Okay. At this next point in time, let us just complete the labeling of some of the components here that do not still have a particular labeling. So let's place some properties here, and then let's just place it as Q1, placing Q1 here, and then this one doesn't have component yet, so capacitor, this is C1, and then let's place 100 UF. Okay, microfarads. Okay, and then let's now start arranging again this. Let's place it this one here. What do we have to change here? Okay, we're now ready for the next step. Let us now connect the connections together by using the wire tool. Wire the circuit together. The When I press the left click, it would have to. Okay, let's now place the wire right here. Let's connect wires at this point. Yes. Then here too. And then this two, and then here. Ay, shucks. And here too. Okay. Okay. Also here. Let's place it here. Connecting this to this. Okay. And then, well, let's connect it to number one. Here, right about here. And then another one here. Right. And another one here. It's there. And then let's connect this wire right down here. So now so the power. And then I think I'll try to adjust this. Connecting to the wire. Yes. Yes. Connecting to the wire. Not exactly the most beautiful attachment. What do I know? Okay. Come on. Okay. And then let's place this. Okay. Then right about here, we go down, stick it on the second pin. Okay. Let's connect this two. Also here. And then what are we missing right here? This one. Here. Oh no. Here we go again. Another here. How about this? Okay. This one. Okay. Let's move to the right part. Yeah, we need something that connects. Okay. And another one right here. Let's just make it a bit clean from this part. Okay, we would have to connect right here. I think we now have connected all the wires together. We will just have to remove this ominous symbol right here. We won't need that. Okay, am I missing anything here? I think none at this point. Okay, we've got our basic wiring together. Okay, after which we would have to save our work now. So let's do it basically by saving as well. We're gonna save the file now. Waiting for the computer to load. Okay, we call this still as this Millare underscore CpE01 Experiment00 tutorial schematic for this circuit, specifically for our drawer burglar alarm circuit. Okay, let's save it now. Yeah, and then we'll have to put a value. Since the pins inside of the BJT right here in this area are not specified, this is because pin assignments vary for different BJTs. So one would possibly could be able to see an error message. So we would just have to place what we call here a value at this point. We would call this 2 and 1711. Okay, and then let's save it. Okay, and then okay, what would we do right here at this point? We're now going to double click. Wait. Yes. Okay. For the next step, we would have to ungroup component. So this is a 2 and 1711 BJT. The base is 2, the emitter pin is 1, and the collector pin is 3. To set this in the schematic, we would have to double click the collector pin, and then let's do it right now. Let's double click this pin. I hope this is what we are supposed to see. Well, let's try to zoom it more. Okay. It's not showing. Okay, I think we have forgotten to first check the schematic for netlist errors. Okay, the selected component, this one does not have the pin numbers, so let us first need to ungroup. Okay, let's click now cancel, and then so after we have ungrouped this component, we could now label each and individual pin together. To set up this in the schematic, let us double click on the collector pin and assign it as pin number 3. Pin number 3. Okay, we've now assigned it as pin number 3, and then let's also assign this as pin number 2 as the base, and then pin number 1 would be our emitter. Okay, so then select the entire component. We'll just take the entire component. Okay, entire component, and then choose group. So let's press component. Let's choose group to make component, and then from the component menu, wait, and then let's assign part ID to be Q number 1. Okay, Q number 1. Now we have Q number 1 right there. If we're going to be using the transistor again, it's probably a good idea to click on it. So let's click component again, and then let's save as custom component, and let's save it as the transistor name, which is in this case 2N 2N1711. 2N1711. Okay, so that's the name of our component right now. Let's change the name now. 2N1711. Okay. Okay. I think I'm going to place again Q1 again. Q1. And then we're going to place the part name here to N1711. Okay. Now let's check again the file for netlist errors. Okay. Now it shows the selected corner is only connected to one wire. This indicates a wire that is not properly connected to or are both ends. So check the wire, either delete or drag the wire's end to the desired connection point, either a corner or a component pin. Okay. Like this. So we would have to do something. So to rectify, we would have to wait. Okay, looks like we have a lot here. Okay, so we would need to press or toggle the snap to grid function off. Select the errant line. Let's yes, and then let's move it. Select the errant line's end and move them into the correct position. Let's move this now. Yes, so these two, and then I think I could see this not matching. Yes, now it's matching. Do we have one more error here? There is one more error right here. Maybe let's check again. Netflix. Okay, I think let's save, because there's no longer no errors found in the schematic. Let's save the file. Okay, our schematic looks like this right now. I think we should try to make it more presentable. Let's put it here. Let's move it in a straight line, I hope. And then let's move this right over there. Just to make it a bit more straight, though not so straight that I would have preferred. Okay, so we now have a fully connected line, or just not yet. Supposedly, at this point, we would have to print the file right now, and then at this point, we'll have to print it. So, to reference as what we have to the layout. Okay, right here we now have a sample printout of the file. Though I think we would have to place our name at this point. I just want to make it a bit formal here. Let's place here. Let's change the name here to Mapua University. Mapua University. Oh no, that's wrong. That's wrong. That's wrong. Let's just cut this. And then place my name. Oh no. Let's change the schematic to what we call here burglar alarm system. Let's just call it here burglar alarms alarm system. A drawer burglar alarm system, which doesn't actually fit in, but now it fits. For this, I'd like to place my name. M. Okay, and then the date. Let's just change it for today. And then page 1. Let's call it page 01 at this point. Okay, I think I'd like to make another final pass here. Final print. Yeah, let's make a final print here. Okay, so we have another printout here. At this point in time, we would now save this file to rest, and then we'll now close the Express schematic So continuing with our creation for our schematic right here for this video tutorial of the Express PCB itself. Um, Let us make the actual PCB for the drawer burglar alarm circuit, and I will show you how to do that here in this application. So we've opened already our Express PCB. When you first open the program, a dialog box appears with links to the quick start guide. Well, we've done that part already, so we would have to continue. So just click OK if you saw that, and then click so you could start a new file. So click a file here and then select new file or new, and then one should choose the two-layer board. We default via 0.056 round, and I mean 0.056 round via the 0.029 hole. So that would be it. And then change bolt clearance for the applied planes to be 0.05. Let's also blank this out. And then let's place 0.05, 0.005, and then let us click OK. Let us hit OK and OK on the warning that appears in the next window. The value set in the default clearance on traces is not valid. So just click again OK. So okay, and then we're going to put also 0.05 here, after which we click OK. Changing the default clearance can prevent solid and thermal pads from connected to the field planes. When you see this warning, just click OK again. Okay. Afterwards, the first thing that one should do is to place all your components onto the layout. Let's start with the resistors. Select the component tracing tool, which is placing tool, which looks like a little IC, and from the pull down menu on the upper right, choose resistor 0.025 watts with lead spacing of 0.4 inch. Okay, this description matches small resistors in RI-024. Put 4 resistors on the schematic. We're about to place 4 now right here. One here, and then another here, and then one larger here, and then another right here. Now double click on each resistor to bring out the property box and assign the resistors with the part ID R1, R2, R3, and R4. Okay, so let us put it back to this, and then let's just move it a bit. Let's just fix this a bit right here, and then moving it here, Okay, now let us label this component. So we would have to place part ID R1. So let us place R1. Okay, R1, and then continue doing that for the next three resistors. So this would be R2, and then the next one would be R3, 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 and then finally the last resistor we would label with a part ID R4. So um, after this point, we would place another component here, which would be the what we call the dip 8 pin. The dip 8 pin package is related to the LM311. So let's find dip 8 pin. Placing dip 8 pin, let us place it here. Okay, very good. And then let's double click the component. So we could place the part ID with the part ID UI. UI. Part ID name is part ID value or name is UI. Okay, so okay, so now let's continue with adding more components right here. First, we would have to find a capacitor with a description cap, radial electrolytic cap, radial electrolytic lead spring, a lead spacing 0.02 inch or 5 millimeters. Okay, and we would try to place it right around here for the moment, and we would label this thing as C1. C1. And then next, we would also add a transistor with the description T039. Transistor with description semiconductor T039, and give it a part ID of Q1. Q1. Q1 would be placed around right here. Okay, so we now have this. Let's label this thing. Let's place Q1. 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 After placing Q1 right there, the label shows. And then after which, let's place a potentiometer to the PCB. Potentiometer with the description potentiometer burns series born series 3386H with 3386H. So we place it right about between around this area for the moment. Well, I think that's a bit too north, but we'll fix that later. Okay, so we would label this as R5, R5, resistor number 5. Okay, so let's see if this works. We would place it first with a name as the video tutorial, so this would be the pre of the first experiment. So this is the PCB version of the schematic of a while back. This is a PCB. So let's place it. Let's save it. Now let us build the components that aren't in the library. But before doing that, I would need to arrange the the components in a way that would be what would have been the schematic diagram would have looked like in the first place. For a moment, let's move it more to the right. Place this also closer. And then the U1. Oh, wrong. We would have to be able to transfer right about here. And then putting the two resistors, the fourth resistor will be raised slightly. Okay. Okay. And then we would move this right about here. And then let's place Q1 to a different area, like right here. Okay, I think we're now ready to build the components that are in the library. So the photoresistor and the buzzer. So let's start with the photoresistor. So like before, the easiest way to build a new component is to start with one component that is similar or familiar to the one that we would like to place towards this PCB. So we look through the components compartment options for a 2-pin component with a 0.1 lead spacing. Of good choice is cap lead. Let's find this. Cap lead spacing of 0.1 inch or 2.5 millimeters. Okay. And then we would place one here around this area. Okay. Now at this part, let us click component and then no, we would have to click first the component that we need to ungroup. So we would ungroup the PCB component. Okay, we have successfully ungrouped the PCB component. And then the next thing that we would have to do is to remove the boundary around the part, which we see is this rectangular thing. So we would have to remove the line, this line. So we're slowly removing the lines. done a bit better, but then we're losing the lines now. Okay. After that, we should draw in a circle. And now at this part, we would like to place an arc. And let's place an arc here. And then let's move the arc a bit. Yes. And then we would adjust the properties of the circle. We would change the radius to 0, 0.825, and with that we got now this kind of look, 0.025, and then we would have to group this again. So let's do this, and then let's press component and group. So it has to make a new PCB component. We would have to now double click on the new component created, and we would like to give it a part ID, a new part ID. I think we have part ID. Okay, so we would name it as PR1. PR1. No changes. Okay. After that part, to use this component again, save our component as component. PR1, and then to use the component again, save the component using component, pressing component, and then save custom design, save custom component. So let's press here, and then save custom component. We would name it still as photoresistor. Photoresistor. And then for the next part, we would have to repeat again this process for the buzzer with just dimensions, and then to create this part we would have to start to find with the capacitor base again, this time with a lead spacing of 0.6 inches or 15 millimeters. It is best to use a polarized capacitor base as the buzzer is polarized. Let us use the axial axial electrolytic lead spacing at 0.6 inches. So after this point, after this placing, it should look like this. Okay, we now have our component, but then we would have to ungroup it. We would have to ungroup components, so we would have to change this and then change that and then ungroup the PCB component, after which we could actually remove this, cut, 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 another cut, remove the lines of the old base capacitor, and after we do that, we should be able to look like this. We would have to add a circle. We would have to add a circle. Circle with a radius of 0.5 inches. Let's see, 0.5, 0.5 inches. Okay, looks like we have enlarged it already at this point. So we would have to check the pins to pull out its accessories. Okay. Um, pull down the pad type and select 0.100 square pad with 0.46 hole. 0.046 hole. Okay. Clearance. Okay. Now repeat it with the other pad. We would have to make it 0.1 and with a 0.046 hole. Pin number 2. Okay. We would now select the parts of the buzzer and we would now group it as a component and give the component ID BZ. For now, we would group to make the PCB component. And now let us move our component to be better. Okay, I think we now have enough clearance. Okay, right about here. Let us also save our component at this point. Save custom component and name it as a buzzer to use again. And then, almost forgot, we would have to have a part ID. The part ID would be BZ1. Okay, now we see BZ1 right outside of our buzzer component. Finally, in this circuit diagram, we would need to add the battery, which is going to be connected by a battery strap to the circuit, and therefore only requires 2 pads. The battery will lie off the board. This is a good opportunity for us to create a part from scratch. Use the pad tool to place a pad with description 0.150 with 0.079 hole to be the positive battery lead. So we would have to find a 0.150 round pad with 0.079 hole to be the positive battery lead. Place it right about here. That wasn't a square pad. It specifically need a square pad. So 150, 150, 150 square pad with 0.079 hole for the positive battery lead, and then we would need to place one right about here. Make this pad correspond to one pin for the battery by choosing it with the select tool, assigning it as to be pin 1. It's now to be called pin 1. Okay. Create another pad, this time using description 0.150 with round pad 0.079 hole near the first pad and assign it to pin 2. Then select both pads, group them together to make a component. Label the component with the part ID B1. So we would have to place this one here. So it's gonna be a circular round pad. A round pad 0150 0.079, and it's supposed to be placed down below. Okay, then we would have to select both pads and group them together to make a new component. Okay, I think we would have to first group them by pressing the component tab and then press group to make PCB component. Okay, and I think we would have to label the ID as SB1. We'll have to save part ID SB1. Save the component as battery strap. Make a component. Okay. Label the component ID with the part ID B1. Battery component strap. Okay, saved. And then next is we would now finally we have all the components on our board. We can now link the schematic file. To do this, click File. Then link schematic to PCB. Select your schematic file. Then you should get a message like this. Okay, so let's link schematic. So let's place it here. Okay, link to the schematic. After which, click OK. Now we would have to click OK. Then we would now click the net tool, and if we would click onto the positive terminal of the battery, we should see something like this. You would see something like this. Click on the other pins. And let's just add this. Okay, so let us click this to check how the parts will connect. Now, let us arrange our components in logical fashion. Our goal is to reduce the length of the connecting wires. We would also like to have a single ground plane on the back and all other connections on the front surface, which means that you want to avoid axing to cross wire one over the other. So that this cannot be avoided. To rotate the component, right click on it and select the desired rotation. For example, it would be nice to rotate R4. Rotate R4, body and text right at 90 degrees. Okay, and then let's arrange all the other parts. Okay, let's move this. Let's rotate this body to the left. Then moving this up. Okay, let's move it right here. Moving also this around here. Okay, and then moving C1 right about here. Okay, let's place again the label, which is E01. Okay, after which let's move R4. Let's move R4 right here, and then moving R3 down right here, and then moving U1 right about this area. moving resistor 5 right along here, and then moving PR1 right about here, and then PR1 and R2, no adjustments, partially needed. And then let's move this right along here. Okay, now we have arranged our other parts so that our board would look like this, a very fashionable and arranged design. Now it's time to draw in the connection lines. Now let us place wires. At this point, let's click the wire tool. We would like to have a 0.1 trace. Okay, and then let's click here. Wait a minute. Let's fix that for a while. Let's stop it first. Let's cut it. Let's cut it. Let's remove that first cut. Okay, it's time to place again. Right about here. Okay. So we would like to place some here and right over there, and we would go down there, and we'd stop right here. We'd push it down to the other 9-volt points in the circuit, positive 9-volt points in the circuit, such as this, and then another here, and then another one here, and then another one here. R5 is a little too close to one power connection, so let's shift it. Shift it slightly and rotate it. Let's move this thing away and then rotate it to the right. Okay, now this is a lot better. And then now let's create the signal connections. The signal connections. Okay, looks like we have our signal connections. Okay. Okay, let us now create the signal connections. Okay, so clicking the line here again, we would place a 0.025 trace. We would connect at let's start at PR1, right about here, and then connecting right here. Let's see how it goes. Connect. We have now connected the photoresistor to the potentiometer as shown. Okay, let's continue this. Repeat this process with other signal modules in the circuit. Once we get to R4, we may notice that the component would be easier to wire if it were flipped. Okay, let's flip our R4. Okay, now let's place here more wires, more straight down. Also one here, stop there, and then another here. Going to the second line, right about there. No, and then connection here. Let's make it look very good. Okay, okay. After which we would have to connect also this. It's an upward line, but one should be okay. Okay, let's connect it here, and then another line for here. Connect these pins, I know. Yes, connect these pins. And then that would be all. I think we should move it slightly straighter, slightly push it down more. Yes, no, yes, make it straight, move it down. Also here, push it a bit down more. Okay, how about pushing this one down too a bit? Nope, no change. Okay, okay, that would be how our line would look like. Now, for the ground plane, let us select place a fill plane tool. Select a green plane tool, which is right above the circle box. Say OK on the informational message that pops up. OK. Say OK. And then create a box that encompasses the entire circuit on the bottom edge of the chip, but leaving a boundary at least 0.25. To do this, choose the green layer on the top bar, then click the upper left corner of the board. Click again near the upper right corner. At this point, your display would look like something like this. Okay, we'll have to draw it mid-plane. Ay, no. Okay. Continue down, then right click to end the box. Okay. We now, after all this, let us use again our network to see where our ground connections are. So so we should click at this point, right click, and then press the bottom layer pad shape over layer pad shape, then thermal pad to the field plane. This will link the pad to the ground plane. The thermal pad has some isothermal isolation between it and the rest of the plane, which will make it easier to solder later on. Thermal pad to the field plane. And then we would also do the same for the other ground pads in our layout. So let's place thermal pad to the field plane also. We would also need to place here. No. Thermal pad to field shape. Thermal pad to field shape. Thermal pad to field shape. Bottom layer pad shape. Thermal pad to field shape. And then looks like this was missed. So let's add also thermal pad to the field plane right here. Let me miss anymore. Okay, this. Another one. Bottom layer pad shape. Thermal pad to the field plane. Thermal pad to the field plane. Okay, that would be all for that part. And then finally, for your own circuit, add your own initials in an unused corner of the chip. Do the initials in the top metal red layer rather than the silk screen layer, because if we use mini boards, the silk screen layer is not included. To add text, click the text tool, and then do the initials on the top copper layer, and then to add text right now. But then I would use my full name, and I will also place my COE, my CPE code number, CpE113L E01 Experiment00, or in this case, this is a tutorial. So maybe we should change it to tutorial. So let's just place it right here. Okay. Right about here. Bit too big, but then let's just adjust it now. Now let's move it a bit more to the left. Also here. Okay, let's just check for the board. Okay, all connections are good. And let's do some basic printout with this circuit just to end our day for this circuit. So let's print out this circuit. Wait, do it a bit more manually. So our printer would be the Canon, just a printer, but then just a regular. Looks like we got the printout. Finally, we would finally the circuit is now done, good and ready for production. This has been a tutorial on how to create a schematic diagram and a PCB on the Express PCB application. This is a drawer burglar alarm circuit, and that would be all. Thank you.